So we are into homework set 19 now, and this problem on page 282 is 77. You're assigned problem 76, very similar to this, and this is solving exponential equations. So maybe the good news is at this point you only have one trick with regard to solving exponential equations, and that is if you have an equation which says I've got some base a raised to a power u, and it's equal to the same base a raised to the power v, then u is equal to v, and you move on and solve u equals to v. That is, you kind of convert this exponential equation to whatever type of equation u equals v is. In this case up here, I believe we're heading towards some polynomial equation, or probably a quadratic equation, and we'll solve that. But that's the technique, making use of this law that allows you to take an exponential equation and turn it into something that you solve. So it's not unusual. I mean, we've got sort of different techniques for polynomial equations, for rational equations, for linear equations, for quadratic. Every type of equation, every class of equation we kind of come across, there's generally some technique that must be used in order to solve it. Now, actually, this chapter that we're in, chapter 5, introduces something. We're not quite there yet. What we're gonna end up doing in chapter 5 is learning how to use the inverse equation. The inverse function of equation. We're gonna look how to use inverses to isolate variables. That's kind of a general trick which can be applied to a lot of different classes of equations. But right now, this is the trick that we're working for. A to the u equals a to the v means u equals v. So what does that mean? Let's go attack this problem up here. My issue is I got a lot of different bases. I got 4s, I got 2s, I got 16s. And what I need is one single base equals some other single base, each raised to some exponent. So maybe you can see that each one of these bases is a power of 2. 4, in fact, is 2 squared, then raised to the x. 2 is 2 raised to the x squared, and then 16 is 2 to the 4th raised to the x. Okay, I'm still kind of not in this form right here. But if I start to apply some exponential arithmetic, I can get there because 2 raised to the 2 in turn raised to the x power is 2 to the 2x. Multiply the exponents. Likewise, let me carry it along. This is 2x squared. This is not 2 raised to the x raised. Well, it is indeed raised 2 raised to the. I'm sorry, it is not. It is not 2 raised to the x raised to the 2, it's 2 raised to the x squared. And likewise here, 2 raised to the 4th in turn raised to the x is 2 for x. Multiply the exponents. All right, one more application of an exponential arithmetic rule. 2 raised to the power u times 2 raised to the power v is 2 raised to the power u plus v. So here's 2. This quantity then is 2 raised to the x squared plus 2x. And it equals the right-hand side, 2 raised to the 4x. And now I've got this in a to the u equals a to the v. A is 2. U is this little quadratic. V is this linear function. And so if a to the u equals a to the v, then u is equal to v. And I can subtract both sides like this. I'm sorry, I guess that's right. I can clean that up a little bit. I'm running out of space here. X squared minus 2x equals 0. I can come up here. I can factor out an x, get x minus 2 equals 0, and then I think we've got something called the zero factor law that says if this quantity is equal to 0, it's because either that's equal to 0 or that's equal to 0. And there's the two values of x which satisfy this equation.